So this is chapter 4 and 5. So the first, I think, 12 slides are chapter 4, which we kind of went over in lab. And then the rest of the slides are chapter 5. Okay, so physical evidence encompasses any or all objects that can establish that a crime has or has not been committed and can provide a link between a crime and its victim or a crime and its perpetrator. So that's the definition of physical evidence. The little bullets I put in aren't coming up on here, so that's frustrating. Sorry. Okay, so physical evidence, it's any objects that can link a crime and the victim or the crime and the perpetrator. Okay, so it's the investigator's responsibility to recognize the evidence, collect, and store it properly. Okay, so it's important to list all the objects that could, oh, not important, it's impossible to list all the objects that could be of importance to a crime. So anything could be physical evidence. I'm mumbling. So it's useful to discuss some of the most common types of evidence, and we did that in lab. So you need to be able to recognize the evidence, collect it, and analyze it. And then at that point in time, you're not going to be the one really determining how important it is. That's going to be up to the jury. So we went over a lot of evidence types in lab. So I think you're okay with what could be evidence. Okay, so evidence can be big and obvious, but it also could be trace evidence. So trace evidence are things like you see on TV, right? So vacuum sweepings, fingernail scrapings, itty bitty tiny things, pollen. Okay, algae is what we're going to look at. So the goal when you're collecting evidence is to prevent contamination. So you don't want anything to get into it, and to protect it so it doesn't get broken down or broken. Okay, so now packaging we talked about in lab, like what things can be put into, like they could be put into little containers. So each different item or similar items collected at different locations must be placed into separate containers. So everything has to go in its own containers, basically what it's saying. It prevents cross-contamination. It seems like he has too many words to explain that. Okay, now chain of custody we also talked about in lab. So it's a list of people who came into possession of the evidence. We have to have continuity of possession, or the chain of custody. So it's just like how one thing went to the next person, to the next person, to the next person. So it has to be there. If there's a space where it's missing, it's going to be hard to use that evidence in court. Okay, now one thing we didn't talk about in lab is a reference sample. So they call it a standard or a reference sample, and I kind of think of it as a control. Like, what are you comparing things to? So physical evidence whose origin is known, such as blood or hair from a suspect, that can be compared to crime scene evidence. So it's something that you can use as a control to compare to evidence so you know what you're looking at. Okay, so it could be soil, it could be blood, it could be glass, it could be hair, it could be fiber. So it gives you something to compare your evidence to. So they call it a standard or a reference sample. Like I'm thinking about the dog hair in lab. So the dog hair in lab, if there's a dog running around, then I would probably try to get a sample of the hair from the dog. Okay, crime scene safety, just remember you're going to have biological specimens of unknown origin. You should have safety training before they let you out to do something like that, so make sure you have gloves. You want to protect yourself. So two reasons you're wearing stuff. You want to protect yourself, but you also want to protect the evidence. So it's twofold. You're not just doing it for one reason. So you don't want the evidence to get contaminated with stuff from you, but you also don't want to be exposed to something that's a hazard. Search and seizure protocols, we didn't talk about this in lab. So any evidence that's removed from a person or from the scene of a crime has to be done in conformity with the Fourth Amendment. Okay, so the Fourth Amendment says it's the right of the people to be secure in their persons, houses, papers, and effects against unreasonable searches and seizure shall not be violated, and no warrant shall issue but upon probable cause supported by oath or affirmation, and particularly describing the place to be searched and the persons or things to be seized. Okay, so they can't unreasonably search you and take things, and you can't do that to a person either. Okay, so I'm missing some of my bullets here. Okay, so there are 4 reasons that the Supreme Court has determined that there are 4 reasons or 4 cases that exist that you could search and seize without a court-approved search warrant. Okay, so they say it's justified in just 4 cases. The existence of emergency circumstances, the need to prevent the immediate loss or destruction of evidence, a search of a person and property within the immediate control of the person provided it is made incident to a lawful arrest, and a search made by consent of the parties involved. Okay, so emergency means you might need to search it if you think somebody's going to be hurt. The need to prevent immediate loss, so somebody's flushing something down the toilet, or they're burning it up or something. If it's on the person after they're arrested. Okay, immediate control of the person provided is made incident to a lawful arrest. And then if someone says, sure, go ahead, search my car, look for drugs. Okay, so consent. Okay, now, there are 2 search and seizure landmark cases. So the first one is Mincy versus Arizona. So in it, an undercover officer broke into a house, and he forced his way into a house, and there was a scuffle. So the house was a house where there was a drug dealer. So the officer was killed in the scuffle. The police conducted a 4-day search without a warrant. Okay, now, when the drug dealer went to trial, he was found guilty. Okay, and then he appealed it, and the court determined and sided with Mincy. So they determined the evidence was illegally seized because a warrant was never issued and the circumstances did not justify a warrantless search. Okay, so no one was at harm. No one was in danger. The police officer was already dead. Oh well. Okay, now Michigan versus Tyler. So this was an arson case. So a fire destroyed a business establishment leased by Lauren Tyler, and a business partner. So the fire was put out in the early morning hours, so I'm thinking like 2 or 3. But the scene couldn't be examined till 8 a.m., so they left the scene. The evidence was seized that day, so like at 8 a.m., and then 4, 7, and 24 days after the fire, but they never had a warrant. So the Tyler and his business partner were convicted of conspiracy to burn the property, so they were convicted of arson. But on appeal, the court determined that the evidence obtained from the initial search was okay, but the searches 4, 7, and 24 days after were acquired illegally. So they didn't have a warrant to go in and search after 4, 7, and 24 days. So they didn't have justification for it. So I guess the moral of the story is don't just go in and take something unless you know what you're doing. Okay, now Chapter 5 is physical evidence. Okay, so the purpose of examining physical evidence. Okay, so there's 2 reasons for looking at evidence. One is identification. Okay, so you want to match it to somebody. Or 2 is to compare it and try to hook it up with something. Okay, so identification is defined as the determination of the physical or chemical identity of a substance with as near absolute certainty as existing analytical techniques will permit. Okay, so you're trying to figure out what it is. Is it a paint chip? Is it a paint chip from a Buick? Is it a paint chip from a 2016 Buick? What is it? Okay, so that's what I wrote on here. What is it? Is identification. So you're trying to figure out what the object is, what the evidence is. Okay, and then comparison is you're looking at the suspect specimen and the standard, which they're also calling the reference, to determine if they came from the same place. So do they have the same origin? So is what you found, your evidence that you found, and what you're looking at the same thing? Do they match? Okay, so how's an object identified? So they have, I mean, it's pretty logical if you think about it, but we have it all written out here. So first you need testing procedures. So an example would be if you have a powdery substance and you think it might be heroin. So then you need a test for heroin. Okay, and you need to be able to do enough tests to rule out anything else that it could possibly be. Okay, now each piece of evidence or type of evidence is going to have its own set of tests, and each set of tests will have its own degree of specificity. So there's going to be like a SOP or like an analytical chart that you're going to follow that says, okay, you've done enough tests. You can definitely say without a doubt or with very limited doubt that this is what it is. Okay, so things that might have to be identified, which these make sense. So the chemical composition of a drug, gasoline, is it in the debris? What's the nature of a explosive residue? So is it dynamite? Is it TNT? Body fluid, so is there blood? Is there semen? Is there hair? Is it wood? Like, did it come from an animal? What kind of plant did it come from? So that's kind of individual identification. Okay, now, how do you know whether the suspect specimen and the standard specimen come from the same place? Okay, so what you're going to do is you're going to take the standard and the suspect, and you're going to do the same tests on them. Okay, it's a two-step procedure. Okay, so first, combinations of select properties are chosen from the suspect and the standard for to compare them. Okay, so you do the same tests on both of them. Okay, and then once you do that, the forensic scientist has to be able to interpret that data and determine whether they are the same or very similar or not the same at all. Okay, so two steps. So the tests and then the analysis. Okay, now, a lot of this is based on probability. And when we talk about DNA, in DNA, when they're doing DNA analysis, they look for 13 different genes, okay, or 13 different regions of DNA in order to determine without a reasonable doubt that something matches. Okay, so it's all based on numbers because you can't say that something is exact, but you can say it's within a reasonable doubt. Okay, so probability, if you've had statistics, it's just the frequency of occurrence of an event. Okay, so if you're just flipping a coin and it's heads or tails, it's easy to figure out the probability, so it's just 50%. Okay, but with these analytical processes and all the variables, you can't really come up with an exact probability. There are some ideas behind how to do that with, like how to limit it down with blood type, and we can talk about that in class. There's an OJ in lab. The OJ Simpson blood thing is kind of cool. Okay, now, individual characteristics are properties of evidence that can be attributed to a particular source with an extremely high degree of certainty. Okay, so it's coming from the Buick that Bob drove when he was at the crime scene. Okay, not just a Buick. Okay, now, in all cases, okay, it's not possible to state with mathematical exactness the probability that the specimens are of common origin. Okay, so you can't say with 100% that they're exactly the same, but you can conclude by doing a number of tests with the right reference standards and the right controls to say that the probability is so high that it's going to defy mathematical calculations or human comprehension. Okay, so the probability is so high that you can't imagine that it could be anything else. So that's the goal. That's what they're shooting for. Okay, so individual characteristics. So examples of things like this. So matching the ridges of two fingerprints. So the comparison of random striation markings on bullets or on a tool. Okay, the comparison of irregular or random wear patterns in a tire track or footwear. So like nobody walks like me. Nobody has the same wear patterns on their shoes as I do. Okay, comparison of handwriting characteristics. If you have a weapon that's broken off, so the fitting together of the irregular edges, it's going to be really, really rare that two things are going to break off exactly the same way. And then matching sequentially made plastic bags by striation marks running across the bag. So if you have trash bags, if you look at them, you know how you tear them apart? They're in a roll, and there's a whole bunch of them, and you have to kind of tear them apart. So if you could tell like that this trash bag came from this roll by matching the striations or the lines on them. So those are just some examples of individual characteristics. Okay, now, lots of time evidence can't be narrowed down to a common origin or individual characteristics, but it can be narrowed down to a group of things, okay? And those are called class characteristics. So that's the difference between Bob's Buick and any 2016 Buick. Okay, so one of the examples the book gives is rather than narrowing a paint chip to a certain car, you might be able to narrow it down to a certain model of car. Okay, or all the Hondas had the same kind of paint, but it might not be exactly the same as well, it could be exactly the same, but you might not be able to narrow it down that much. There might be too many of them. Okay, so here's some examples. So, for example, what's the probability that a nylon fiber originated from a particular sweater or that a paint chip came from a suspect car in a hit and run? Okay, so it's really hard to use statistics to derive this probability data because there's so many different, I'm just thinking about like how many kids right now are wearing Converse tennis shoes, right, or Vans, or Uggs, right? So how many Ugg footprints are out there? So it would be really hard to narrow it down based on just the Uggs. So what you have to do, right, is collect a whole bunch of data and then put it all together, kind of like triangulate it is what I always say. So you take a bunch of data from a bunch of different things and then hopefully you can link it together. There are statistical databases. So data gets collected. It's the responsibility of the criminalist or the forensic scientist to start collecting data about the statistical significance for class physical evidence. So you could say, okay, well, we know there were 20,000 of these made, and so the odds of this are 20,000 in whatever the population is. Okay, so you do have to remember that most of the time things cannot be linked definitively to a single person or object. Okay, now, the value of this class physical evidence lies in the idea that you could corroborate events that are with data. So, and you can use science, which is going to take out, hopefully, human error and bias to prove it. So the idea is you can take the class evidence, which you can't tie to a specific person, but if you have enough of it, you can link it together to make a case. Okay, the chances are low of encountering two indistinguishable items of physical evidence at a crime scene that actually originated from different sources. Okay, so the idea behind class evidence is that they're going to have a collective presence. So when one is dealing with more than one type of class evidence, their collective presence may lead to extremely high certainty that they originated from the same source. So if you have Uggs, and then they had blonde hair, and then you could just kind of layer things up, and that helps it. So as the number of different objects linking an individual to a crime scene increases, so does the likelihood of that individual's involvement of a crime. So you're just adding pieces of evidence together. You can't just use one piece. Okay, now you have to also remember that a person may be exonerated or excluded from suspicion if the physical evidence collected at a crime scene is found to be different from standard reference samples that are collected from that subject. So you can remember that somebody could be exonerated too. Okay, now crossing over. So evidence can cross from a class evidence to individual evidence, but there's lots of questions, right? So there's always like the what if thing. Okay, so an example is how many striations are necessary to individualize a mark to a single tool and no other. So how closely does it have to match? How many color layers individualize a paint chip to a single car? How many ridge characteristics individualize a fingerprint? How many handwriting characteristics tie a person to a signature? So these are the things that a defense lawyer is always looking at. And I'm like, well, you're this close, but there's still reasonable doubt. So these are things that can always be argued and discussed because there's no right or wrong. It depends on the whole scene. Okay, so natural versus evidential limits. So one thing you have to remember is there are practical limits to the properties and the characteristics. So the techniques that we use are so sensitive that there are variations that you can see even though two things are from the same place. So there are natural variations. So that's kind of weird to think about, but things are so precise that you're not sure when you need to stop. Okay, now forensic databases are super important because this is kind of how everything is organized and how you can actually use the data that's being collected. It's pretty neat. Like if you could be a database person or if you could work with large data sets and you liked computer programming, these kinds of things would be the way to go, especially like the DNA stuff is growing and growing. Okay, so the first one from the book is the Integrated Automated Fingerprint Identification System. So I'm not sure how you're supposed to say it. IAFIS. It's a national fingerprint and criminal history system maintained by the FBI. So fingerprints are going into it. So I just want you to be able to match them up. Okay, so CODIS is Combined DNA Index System. So it's a way for federal, state, and local labs to exchange and compare DNA profiles. So we'll talk about that more as time goes on. NamUs is the National Missing and Unidentified Person System. So it was started in 2007. So it's a centralized repository and resource center for missing persons and unidentified decedent records. Okay, so unidentified bodies. So this one kind of freaks me out. The other ones are harder to get into, but this, it's a free online system that can be searched by medical examiners, coroners, law enforcement officials, and the general public. So you could get in there and start looking around. It's comprised of 3 databases, all of which are open to the general public. Whoops. Okay, so you can skip that because I put this slide in again. I try to compress things. Okay, now this is the National Integrated Ballistics Information Network. So it's for firearms. So the analysts can acquire, digitize, and compare markings made by a firearm on bullets and cartridge casings. So this is kind of cool. So 1.6 million items have been entered into the database, and 34,000 hits have been recorded. So that's pretty cool. Okay, and then there's an automotive paint data query. So internationally, it contains chemical and color information pertaining to original automotive paints. Okay, so it's got about 13,000 vehicle types in it. Then there's shoe print and tire print. Okay. The shoe print database I tried to get into before class, and you have to demonstrate how you're using it. So it's a comprehensive shoe sole database. Contains more than 22,000 footwear patterns, and then there's 6,000 records in a tread mate, which is tire tread patterns. So those are cool. And then the next part, he's got this stuck in on the end of the chapter. So the collection and examination of pollen and spores is called forensic palynology. I never have heard it called that, but we've looked at spores before and pollen. So what they can do is you can look at pollen. They're different plants. The pollen is extremely distinct. So if you have, it takes a specialized microscope though. We don't have any of these SEMs. We could try to do it with the light microscope, but you can, like certain plants are going to have pollen at certain times of the year. So you can narrow down like a window of time and a region based on what pollen is found. So you can link a subject to a crime scene, or a suspect or an object to a crime scene or a victim. You can prove or disprove an alibi. I mean, it's really cool, and the pollen, it's actually really pretty. But yeah, but he put that in the end of this chapter. I don't know. Okay, so I think that's it. It seems like I talked really fast through this, but you guys can read more in here about everything. There's more details of everything, but I just want you to hear the basics for right now.